Alright, so in this video we're going to learn how to simplify radicals, and that's necessary when we want the most exact answer to something instead of decimals. So to do that, you need to know your perfect squares. And to find your perfect squares, it's a number times itself. So for example, 1 times 1 is just say 1. So 1 is a perfect square. 2 times 2 is 4, so 4 is a perfect square. 3 times 3 is 9, so 9 is a perfect square. 4 times 4 is 16, so 16 is a perfect square. 5 times 5 is 25. 6 times 6 is 36. 7 times 7 is 49. 8 times 8 is 64. 9 times 9 is 81. And then 10 times 10 is 100. Okay? So these are the most common perfect squares. And they are called perfect squares because if you take the square root of any of these, you will get a whole number. So for example, the square root of 36 will give you 6 because 6 times 6 is 36. Okay? The square root of 25 is 5 because it's 5 times 5. Okay? So you need to be able to know these perfect squares so that we can save some time when we solve these problems. Okay? So let's look at some examples. I need to find the square root of 20. And to do that, I need to see if any of these numbers will go into 20. So I need to try 1, 2, 3, 4, and etc. So one way to do this is to do a factor tree like we have done in the past. So I know 20 is 2 times 10, sorry. And then I know 10 is 5 times 2, and bring down that last 2. So you can do a prime factorization of all these numbers, and that would represent the same thing as square root of 20. Now when you take the square root of something, you will get just one number on the outside. It's because this has a base of a 2 on the outside. So if you have 2 of a number, you can take them out of the square root. So for example, I have 2 2's. So when I take out 2 times 2, I would only take out 1 2. And I would have square root of 5 left in the radical. Okay? So the reason this works is 2 times 2 is like a 4. So what this is saying, it's saying the square root of 4 times the square root of 5. But I know the square root of 4 is 2. And so all that we did was we did 2 root 5. Okay? So 2 different ways to think about it. You can break down the prime factorization, and if they have 2 numbers in common, you take them out and write them once, and then you see what's left on the inside. I'm going to try a different way. You can try this way as well. So 125 is a big number that I don't know. So what I'm going to do is pull out my calculator and see what goes into 125. I'm assuming 5. So 125 divided by 5 is 25. So this is the same as saying 5 times the square root of 25. Okay? So 125 is 5 times 25. Now, I know the square root of 25 is a 5 because it's a perfect square. So what we can do is say that this is a 5 because the square root of 25 is 5, and I'm left with this root 5. So my answer would be 5 root 5. Okay? Another way you can think about it is the square root of 125. You could just break it down into 5 times 25, and then break down 25 into 5 times 5, and bring down this 5. And once you get to the prime factorization, we can kind of see if there are 2 of the same number and then take them outside. So I see 2 5's, I can take them out and you write it once, and you are left with a 5 in the middle. Okay, so either way that you like to solve these, it's up to you. You will get the same answer no matter what. Okay, so let's try one more. 45 is divisible by 5, so 5 times 9. So I know the square root of 45 is going to be the square root of 5 times the square root of 9. Okay? I know 9 is a perfect square. So the square root of 9 is a 3. So I can just go ahead and jump to that's a 3. And then the square root of 5 cannot be simplified. So I would write my answer 3 root 5. So you put the square root at the end of the problem. Okay. Again, I'll show you the other way of looking at it. If you have square root of 45, you know it's 5 times 9. 9 breaks down into 3 times 3. You can bring down that 5. Once you have them all in prime numbers, you put a square root sign. And if they have two numbers in common, you take them out and write them once. Root 5 was left on the inside. So either way that you think is better to find the answer, pick your favorite way. But that is how you simplify your answer, okay? So we do not want any decimals with these. So let's take a look at the bottom ones. These look trickier because they have a number on the outside, but it's just a little bit more work. So let's look at this one over here first. So I know 12 would be a 4 times a 3. Okay, so 12 is going to be 3 times 4 with roots. Okay, now the square root of 4 is a perfect square, which is 2. But I'm going to go ahead and bring that number from the outside. The square root of 4 is a 2. And then the square root of 3 cannot be simplified. And I'm going to go ahead and bring down that 10. And I'm going to multiply the numbers on the outside. So I would get 20 root 3. Okay. All right, let's try this one over here. I'm going to do the other method to see if that helps you guys. I know 50 would be 5 times 10. And then 10 would be 5 times 2. And bring down the last 5. So once you have the prime factorization, go ahead and write your square root. You are going to have to bring down that 8 on the front side. All right, so now see if you've got any two numbers in common. So I've got 2 5s. So I'm going to take them on the outside and write 5 once, which means I'm going to multiply 5 times 8. And I'm left with that root 2 in the middle, so I'm going to bring that 2 down. So your final answer would be 40 square root of 2. Okay. A way that you can check your answer is to type both of these in the calculator and see if you get the same decimal. So for example, I can type 8, and then the square root is in blue right here, so you hit second x squared. So if I type in 8 root 50, I get this funky decimal. So if I type in this number down here, I should get the same thing, because I'm not changing the problem at all. I'm just changing how it's written. And I do. So I know that this form is the exact same as this form. Okay? So why don't you press pause and try this last one on your own. Two ways. The first way I did it was I broke it down with the square root method, and I knew 45 was 9 times 5. I know the square root of a 9 is a 3, and so I just did 8 times 3 on the outside to get 24, and I kept bringing down that root of 5. The other way you could have done it is to break it down into its prime factorization. So I did 9 times 5, and then I broke 9 down into 3 times 3 times 5. I had a pair of 3's, so I took a 3 out, and I only wrote it once. And with that 8 on the outside, you're going to multiply those numbers to get 24 root 5. So either way, you like to do those problems. Okay? So let's take a look at some fractions. Okay? Fractions are easy when you have prime number, or not prime numbers, perfect squares. So what you have to do is you break the fraction into the top and the bottom. So this would become square root of 4 over square root of 9. Okay? And then if they're perfect squares, it's going to be easy because the square root of 4 is a 2 and the square root of a 9 is a 3, and you're done. Okay? So again, if you've got perfect squares as your fractions, it's going to be easy. Let's take a look when they are not. So for example, this is going to turn into square root of 6, and it's going to turn into square root of 25. I know the square root of 25 is a perfect square, and the square root of 25 is 5. Square root of 6, though, can we break that down? It would be 3 times 2, and I would not have any numbers in common, so you actually are going to leave it as square root of 6. So there are some that cannot be broken down, and square root of 6 is one of them. So square root of 6 is simplified. Okay. Over here, this is going to turn into square root of 10 over square root of a 9. And I know that the square root of 9 is a 3. So that's going to reduce. But square root of 10, let's see if that can reduce. Square root of 10 would be 5 times 2. And then I would not have any numbers in common. So square root of 10 is as far as we can simplify it. Okay, so that would be our answer. So you have to kind of check to see if you can simplify the top and simplify the bottom. Okay, all right, let's take a look at some more challenging fraction problems. And these are when they're not perfect squares. So what we're going to have to do is break it down into square root of 12 on top, and then square root of 75 on bottom. So what you have to do is break down the top and the bottom separately. So I'm going to hop down here and do square root of 12, and then I'll also jump down here and do square root of 75. Okay. So square root of 12 would be 3 times 4, and then 4 would be 2 times 2 times 3. So I've got a pair of 2's. I'm going to take it out and write it once, and then a 3 was left on the inside. So this top part is going to be 2 root 3. Okay. Now to break down this 75, that will be 5 times something I cannot think of right now. 75 divided by 5, 15. So that will break down to 5 times 15. And then 15 would be 5 times 3, and bring down that 5. I have a pair of 5's in common, so I'll take it out and write it once, and then get root 3. So 5 root 3 is on my bottom. Now I cannot simplify 2 divided by 5, so this is my final answer. Okay. All right. Let's try this one in the middle. And for time's sake, we are going to skip this problem here. So again, this breaks down into square root of 50 over square root of a 9. And I know square root of a 9 is 3, so that was a perfect square. So I only need to break down my top, my numerator. So 50 would be 5 times 10, and then 10 is 5 times 2 with a 5. So I have a pair of 5's. I'm going to take them out and write them once. And then I would get 5 root 2. So now that is what is on top, 5 root 2. And since I cannot reduce this fraction right here, I would leave it. Okay. Let's say, for example, you had 6 root 2 over 3. If you are able to divide those numbers, you will. So 6 divided by 2 would be a 2, and then you would tack down that root 2. So you always have to double check to make sure if you can divide these two coefficients out front. Okay. But that is how you reduce fractions. And so now you can work on your IXL, EE1 and EE2, or I do have coloring worksheets if you would prefer that. So thanks for watching.